Hello everyone. I hope everyone is good. Everyone is fine. So we are again here with the next rapid revision session for the very important chapter, that is coordination compound. So if I tell about the most important, one of the most important chapters in whole chemistry, that will be of course the coordination. Chemistry has top 5 place in that for sure. Sometimes it has the day, it can easily have 3 to 4 question or at least 3 question or 2 question for sure from this chapter, because there are a lot many concepts are there, and with the practice it becomes good. That's why here practice and the type of questions, or you can say as many number of questions solving, is very much important. So let's start with a very important chapter, that is coordination chemistry. Chaliye. So now in coordination chemistry we are going to, I will not take much of the time, and I will not much will be focusing on the theories. I will be just focusing on the question solving, but still basic things, few of the fundamental things I would be revising. I would be telling you how it works. Okay, so let's start without wasting a second. Now some important terms pertaining to coordination compound. What are these things? I hope, let's see what is coordination compound. Wherever you see such kind of thing, there is a bracket. Like if I just write K4FeCN6, let's say that there is a compound like that, or there may be another compound something like that, like what we can say, CO NH3 whole 6 Cl thrice. Let's say that there are two different compounds. Can we see there is one thing that is common, that is this bracket? This, you can say, that large bracket. This large bracket is nothing but it is something that tells you about that this is a coordination compound. And everyone, I hope we all know that, because I'm not going to talk much about the theories, basics of the Werner's theory, and these things I will complete here only when I'm talking about the some important terms. Now, first of all, what are the important terms? Whatever is this part you are looking at, it is called coordination entity. Coordination entity, or it is also known as coordination sphere. Coordination sphere. And whatever is the three-dimensional, or you can say it's geometrical, if you talk about its geometry, it is nothing but it is called coordination polyhedra. Coordination polyhedra. If you just think about that in three dimension, how it is looking, or what is the structure, then you will call it coordination polyhedra. Acha. So what is this? Here we can see that there is one metal inside it. This metal is nothing but this is called central metal atom or central metal ion. If it is having some charge, it will be called central metal ion. If it has no charge, it will be called central metal atom. What are these things? These, I think you can see that CN6. What are these things? These are called ligand. These are called ligand or ligand. Whatever you want to see, you can just say that. And what is this? This is nothing but this is called coordination number. Coordination number is nothing but the number of ligands around, or ligand around the central metal atom or central metal ion is called, it is what? Coordination number. And what is this? This outside. This is nothing but this is called, because we see that the whole part is called coordination entity or coordination sphere. We also can say that coordination ion, right? What we can say, this is nothing but that whatever is outside, it is countering the ion charge. Let's say that this is having the overall charge -4, so potassium has to give counter it to have the neutral molecule. For neutral molecule, whatever is the negative, the same positive should be there. So to counter that negative, there should be some same amount of counter positive ion charge should be there. So therefore they are called counter ions. I hope it is all very clear. Now whatever is the charge on the central metal atom comes, here the charge on central metal atom comes is +2. It is called oxidation state, or you can say oxidation number of central metal ion. You will not call central metal atom, because central metal atom has the 0. Whenever it is in atomic form, it will have the 0 oxidation number. Okay, now let's talk about it. Here also you will see the same thing. Can you just tell me? I will just ask you, what is this Cl? Chloride is there. It is here acting as the, it will be, because here the overall charge was negative, so it was what? Overall negative, or you can say anion. What was that? Complex anion. Whereas here the complex was +3, so it is what? Complex cation. It is what? Complex cation. It is also complex entity or complex sphere, or coordination sphere. And if you just see it in the three-dimensional way, it will be called coordination polyhedra. What are these 6? These are nothing but the 6 different you can say ligands are around it, so therefore it is coordination number. And what are these? There are ammonia here. All the 3,6 ammonia are called ligand. These are counter ions. I hope it is all very clear, not a big deal. And what is the charge on cobalt here? +3. So it is the oxidation state or oxidation number. According to Werner's theory, I am directly telling it because once these, coordination sphere or coordination compounds were or found out, na, on that there were many of the theories were given for explaining the bonding. So first and foremost theory was given by Werner. So basically Werner told something about any of the central metal has two kind of what to say, valencies. One is primary valency, another is secondary valency. Primary valency is something that is nothing but whatever is the oxidation number. Can you see that oxidation number here is +2? Here it is how much? +3. So what is the primary valency for iron here? +2. Or what is that? Or 2. Here it is how much? 3. So this primary valency is always satisfied by some counter ion or some of the ions. So what we can say here, cyanide is going to whatever is +2 is there. If whatever is the negative part for this, how much of the cyanide is needed? 2. So 2 cyanide is here contributing in quenching its thirst for the this +2 charge, right? Or we can say that ki wo +2 kaise cancel hoga by 2 of the cyanide. So it will be its primary valency. But what is the secondary valency? Secondary valency is nothing but the coordination number. Whatever is the coordination number, that is called secondary valency. So how much is the coordination number here? 6. So what will be the secondary valency? 6. Okay. Here what is there? Because we can see that here it is 6. So therefore what we will say that secondary valency is 6. But what is the primary valency? Whatever is the charge here +3. So therefore this 3 is being, you can see, cancelled by these fluorides. So of course they are something that is cancelling, or that is, you can say, compensating its primary valency. Is it okay or not? So this was something that I have also taken Werner's theory into the approach here. Now there are something that is classification of ligands on the basis of charge. So there may be anionic, there may be neutral, there may be cationic ligands. If anionic are there, what you will do, you will just add O at the last. What I'm talking about, if let's say ide are there, let's say there are ide, so ide converts into ido or just O. So you can either say fluoride is there, so fluoride will convert into fluorido or fluoro. Fluoride will convert to chlorido, fluoro. Sulfide will convert to sulfido or sulfide. That's it, not a big deal. Okay, now sulfate. Now 8 converts into ato. 8 converts into ato, while ite converts into ito. What it will convert into? Ito. I hope it is all making sense, not a big deal. Next is neutral. In neutral ligands, you just put the names as it is. Generally, like CO is there, so what you will call it? Carbonyl. NH3 is there, you will not call it ammonia, but you will call it amine. AMMINE. And what is this? Water. Water ko kya bologe? Do not say water, you will call it aqua. Aqua. What about cationic ligands? Once cationic ligand is there, at last you will have to add suffix that is called em. Em, that tells about that it is positively charged. NO plus, so it is nitrosyl. NO is nitrosyl. So what we'll say? Nitrosilium ion. What we'll call it? Nitrosilium ion. And we also call it nitrosonium ion. Nitrosonium ion. And what is that? NO2 plus, it is nitronium ion. Nitronium ion. Not a big deal. I hope these things already know. Next, on the basis of denticity. Denticity is what? How many number of bonds a ligand is forming with the central metal atom or central metal ion is called denticity of that coordination or that ligand. Monodentate means it is only having how many of the bonds it is forming with central metal? 1. So what are the examples? I hope you can see that chloride, H2 and H3, because it is only giving the through one lone pair. So because why are we thinking about lone pair? Because this coordination, whatever compound is formed here, whatever is the ligands are there, they are acting as the Lewis acid. So they are donating the electron, a lone pair. Who is taking that lone pair? The central metal atom having the vacant d orbital, it is taking its lone pair there in the vacant d orbital. So therefore, what is central metal here? Central metal atom or central metal ion is acting as ion is acting as Lewis acid, while these counter ions, not counter ions, but these ligands are acting as Lewis base. Please keep in mind these are Lewis base, while central metal atom or ions are Lewis acid. Not a big deal. I hope it is all understandable. Next, Monodentate, I have told you. Bidentate, bidentate are those that can form two bonds, not a big deal. What are the example? Good examples are there, like ethylene diamine is there, oxalate is there, diamine. So these things, you can see that it is ethylene diamine En. We just call it En. Oxalate OX, glycinate GLY. Now see, because it is, can you see? Just a minute. What we can say? Glycinate. How many? You can say glycine. Have you ever thought of glycine? What is that? Or that amino acid. C H H C double bond O OH and NH2. It is the first exam सबसे fundamental amino acid is glycine. Now what do you do? Just remove hydrogen, it will become glycinate. Can you see that nitrogen has one lone pair? It will give from one from here and one from here. So how many of the denticity you can see? Two. So what we can say? Two bonds it is forming. So therefore it is what? Bidentate or didentate. Okay. Now, can you see that in these cases, the lone pairs are given by the same atom, so therefore it is symmetrical bidentate, while it is what? Asymmetrical bidentate. It is asymmetrical bidentate ligand, while it is symmetrical bidentate ligand. I hope you understand what I'm trying to say. Next, here dimethyl glyoxim, can you see that? Then next here acetoacetate. So please, these things are there. Okay, what are the important ones? I'm telling you that generally we see many times: oxalate, En, glycinate, not others. Then polydentate, one of the most important, EDTA, ethylene diamine tetraacetate. Ethylene diamine tetraacetate, can you see that? How many, what is the denticity? One through this nitrogen, one through this nitrogen, one, 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 one. How many are there? Four here, two here. So how much is the denticity? Denticity is going to be 6. Can you see? Now, it can also be ethylene diamine triacetate ion. Triacetate. Consider that one becomes COOH. So how many of the place it is giving? 3. So 3 plus 2, it will become, denticity can become 5 also. Even it may become ethylene diamine, not not tri, but it may be ethylene diamine diacetate. So now insert, or triacetate may be what we can say, tetraacetate ion. It may also have, let's say that there one H is there, one more H is there. How much negative is there? 2 negative. And how much of lone pair there's? 2. Therefore, there will be from 4 side it will be donating. So in such case, what will be the denticity? 4. So its denticity can be changed, right? So its denticity can be changed. So it can bind through nitrogen and 4 oxygen through central atom. But whenever, if nothing is given, always remember that that EDTA has how much of negative? Negative of 4, and denticity is how much? 6. Not a big deal. I hope you understand it. Next is going to be some other bidentate ligands, polydentate ligands. You can just see like diethyl ethylene triamine. Can you see there is diethylene is there, means 2 ethylene part, can you see? And how many amine? 1, 2, 3. How many of the lone pair are there? 1, 2, 3. So from 3 side it will be giving, so denticity becomes 3. Then it may be triethylene tetraamine. So how many of the ethylene you can see that? Just a minute. How many of them amine? 1, 2, 3, 4. So can you see from 4 places it can donate this. So therefore denticity is 4. How many of ethylene is there? 1, 2, 3. So triethylene, I hope you understand how the name is given. Triethylene tetraamine or triene, it is also called as triene. Not a big deal. Aage badhenge. Next, ambidentate. Ambidentate are those ligands which can donate the lone pair through more possibilities, or one or more, more than one kind of the atoms. So what we can say, like nitrito, or we also call nitrite. Have you ever thought of nitrite? NO2. So it can donate through oxygen as well as through nitrogen. If it is donating through oxygen, it will be called nitrito O. If it is donating through nitrogen, it is called nitrito N. Can you see? So therefore, if nothing is given, let's say it is giving only nitrito. So nitrito means you have to consider, see, it may be nitrito N as well as O. So when it is just nitrito, so just you will have to consider it is nitrito O. Okay. Now thiocyanato or isothiocyanato. If it is giving through sulfur, nitrogen through isothiocyanato. Not a big deal. Flexidentate ligands having variable denticity which depends on the nature of the metal. For example, for EDTA. EDTA, as I have shown you, as I told you, it can show 6, 5, 4, 3, anything it can show, right? Or similarly, some other examples are also there. Sulfate. It can also call it be like carbonate. How the sulfate and carbonate? Consider CONH3 whole 4 SO4 is there, and Cl is there. Or what we can say, CONH3 whole 4, whole 5 SO4 here. Can you see sulfate is there? Can you see how many ammonia is there? 5. If 5 ammonia is there, here cobalt is what? Plus 3. Here also plus 3. Cobalt plus 3 means it will show 6 coordination number. Means here it is going to have what to say 6 coordination number. So in such case 4 is ammonia. So 2 will be given by sulfate. So here metal will be something like that. Sulfate S double bond O minus O minus double bond O. It can give proof 2 oxygen. But here, because there are 5 taken already by ammonia, so how much remaining? Only 1 coordination number is remaining. So in such case, how it will be giving? So here, density is 2. But if like that, MS double bond O minus, through oxygen. So here density is how much? 1. I hope you understand it. So it can change its density depending on what is the need. So on that need, if it is changing, so it is called flexi-dentate because it is flexible with its approach. Next, chelating ligand. What are the chelating ligands that can form chelate? Chelate is nothing but that stabilizes any of the complex. It is something that in chemistry, in all over inorganic, organic, wherever you go, if the chelation increases, what happens? Potential energy decreases, stability increases. So therefore, always remember, there are many effects that is related to that. We do not have to go into it. Just always remember, once the chelating ligand is there, one effect is there, that is called chelating effect. And chelating effect gives what? Chelating effect gives stability or increased stability. Increased stability. Okay. Now, always remember what is the number of chelate will be formed. Whatever, consider if there is any denticity. Always remember number of chelates formed by a ligand will be equal to denticity minus 1. Denticity minus 1. If something has denticity 2, so how much of the chelation will be, or how many ring will be formed? 1. So chelate is nothing but it is talking about ring. Okay. Now can you see ethylene diamine is there? Ethylene diamine को हम लोग और क्या बोल सकते हैं? Ethane 1,2 diamine. It is also, you can say that it is IUPAC name. Now, so here what is the density? 2. So how much of the ring it is forming? 1. Can you see? Again here it is 2 density. How many of the ring is there? 1. Can you see? Not a big deal. Easy. चलो आगे बढ़ेंगे. Now come to the next part, that is sum of the coordination number and oxidation number of the metal M in the complex this. Okay, where En is the ethylene diamine, not a big deal. आइए भाई जरा ध्यान से देखेंगे and करेंगे इसे. So here oxalate has how much of the negative? Can you see? 2 negative. How many of the oxalate is there? 1. And chloride has how much of the negative? 1 negative. So M will have how much of the, because ethylene has how much of the charge? Ethylene diamine has the charge 0. So metal has how much of the charge? For -3, it should have +3. Any doubt? No doubt. So metal has +3. So what is that oxidation number? Oxidation number on metal is 3. What about the coordination number? Ethylene diamine, tell me what is the density? 2. And how many ethylene diamine is there? 2. So how many is there? 4. And what about C2O4 oxalate? It also have density 2. But how many oxalate is there? 1. So therefore 2 ones are 2. So how many of the overall coordination number comes out to be? Coordination number equals to 6. So coordination number 6, oxidation number 3. 6 plus 3 is how much? 9. Because it is asking for sum of both of them. Any doubt? No doubt. PYQ. Next, a coordination complex core atom or ion is known as Bronsted-Lowry acid. Okay, Lewis base, Lewis acid. I hope you all know that because metal takes the lone pair. So therefore it is Lewis acid, not the Lewis base. Any doubt? Okay, आगे बढ़ो. The correct order of the stoichiometric of AgCl formed when AgNO3 in excess treats with the complex CO and this and this. Okay, no problem. Please read NCERT Varna's theory from my side. It is extra read that you have to go through. And please note down all the colors, whatever is given in NCERT. Very important. The question have come from JEE mains also as well as in NEET. Please go and check the PYQs. And in JEE mains, because it is following this trend, so later on it may also come in the NEET. Please. Next. चलो भाई जरा ध्यान से देखना. Always remember कि whatever is inside, whichever ion is inside the coordination polyhedra, that is non-ionizable. Whichever ion is outside, that can only be ionizable. What I'm saying, अगर कोई भी चीज coordination polyhedra के अंदर है, that cannot show or that cannot break into ions, but what can be ionized, that is outside. ठीक है, बस simple है. Now can you see cobalt here is how much? +3. Cobalt here is +3, so therefore coordination number comes to be 6. Here also everywhere coordination number is going to be 6. Coordination number is 6. Coordination number here also is 6. Can you see? Coordination number is going to be 6 because it is plus 3 plus 3 plus 3. So can you make it? Yes, we can make it. So first of all, how many of the ammonia you will see? You'll take here CONH3 whole 6, because according to Werner's theory there are two types of valencies. One is primary, one is secondary. So first of all the secondary valencies will be you know cancelled or will be taken by those which are non-ionized. So ammonia has the charge how much? 0. So first of all, they will occupy all the secondary valencies, or you can say all the coordination number. So all the chloride will go outside. So all chloride are outside. What about this? Can you see? For the second molecule, it is CO. Ammonia first of all will take all the secondary valency. That is how much? 5. And now how many is remaining? One more is remaining. But how many chlorides are there? 3. So one chloride will be taken inside the coordination polyhedra. So how many is outside? 1. What about this? What about this? This comes out to be because coordination number is going to be 6. So CONH3 is going to be how many? 4. And how many chlorine will be taken from here? 2, because coordination number should be 6. So take Cl2 inside, and how many chloride outside? 1 chloride outside. So in such case, what you are going to do? You are going to react with AgNO3. AgNO3, that too in excess. Now AgNO3 will react with 3 chloride. It will give you 3 moles of AgCl. Yes or no? This nitrite and chloride ion exchange. So how many of the moles of AgCl will be formed? 3. If you just react with, because only these 2 chlorides will be here ionized. Here 3 chlorides will be ionized. Here how many chlorides will be ionized? 1. So what we can say? It will give 2 AgCl, and here it will give 1 mole of AgCl. So why? Because 1 chloride is ionizable. So when AgNO3 reacts with it, so what will happen? I hope you understand it. Okay, no doubt. So 3 moles, 2 moles, 1 mole. So 3, 2, 1 is the correct option. That is option B. Next is the compound PT. This does not react with AgNO3. The compound can be represented as. So what we can say? These chloride are not outside the ring, but they are inside the ring. Then only they will be non-ionizable. Yes or no? So if they are non-ionizable, means completely inside the polyhedra. Now in such case, what we can say? So this compound can be represented by. Can you see? PT? No. Only option B. Any doubt? No doubt. Which of the following will give maximum type of cation in the water? Can you see that this is not the coordination compound? This is double salt. It is double salt. It is double salt. Double salt gives all the ions. Test for all the ions. So how many of the ions will be given? 1 potassium ion, 1 chloride ion. It's not 1. I'm talking about what are the different types of ion it is going to give. Mg plus 2 and chloride. Chloride is same. So there are 3 types of ions. 3 types of ions. Here it is going to give potassium ion and 1 complex ion. Can you see what it is going to give? Again, it will also give 1 potassium ion and 1 complex ion. So how many types? 2 types. Here also how many types? 2 types. Can you see? Here also 1 potassium ion and 1 is complex ion. Here also it is going to be 2. So option A is a very good, so easy one, right? Next, the coordination number of central metal ion in the complex this is. Can you see? Oxalate. Oxalate is how much? -2. Overall how much? -2 into 3. That is -6. So, why am I doing this? Coordination number it is asking. Huh? So oxalate has how much of the density? Density is how much? 2. How many of this is there? 3. Therefore, how many of the bonds it will form? 6. So what is the coordination number? 6. Option 6. See? Next, which of the following complexes are heteroleptic? Now see, homoleptic compounds are those compounds where all the same ligands are there. Heteroleptic matlab where different ligands are there, or more than one type. More than one type of ligand is present. Can you see how many types are there? It is all same. So it is homoleptic. It is homoleptic. It is, can you see another different? Can you see? It is heteroleptic. Heteroleptic. So option B is the correct option. Can you see? Option D is also correct, because here also it is two different. It is homo, while it is hetero. Any doubt? No doubt. Very good. Next, the spatial arrangement of the ligand attached to the central metal atom ion called. It is called, I hope you all remember, coordination polyhedra or coordination polyhedron. Next, ethylene diamine tetraacetate EDTA is hexadentate, yes or no, and with 4 oxygen and 2 nitrogen. Not a big deal, correct? Yes or no? बिल्कुल सही बात है भाई. अरे क्या है ethylene diamine tetrahedrite? You have to remember, I have already told you, CH2, CH2, N, N, COO minus COO minus COO minus COO minus 2. How many of these places are there? So nitrogen के through 1, 2, 2 nitrogen के through, and how many oxygen? 1, 2, 3, 4. 4 oxygen, 2 nitrogen. So how many? 6 hexadentate. A chelating agent has two or more than two donor atoms to bind to a single metal. Which of the following is not chelating agent? Thiosulfato, thiosulfato, S, S2, O3, 2 minus. No भाई, S2O3 कभी नहीं. S double bond, S double bond, O minus कैसे बनाएगा? It is not going to form. No, nothing. Oxalato, yes, it forms. C double bond O, C double bond O minus, yes, it gives through it. Of course, it can go give through it. So oxalato, EDTA, हाँ भाई. Ethylene diamine, yes. So what? अच्छा, not acylating, not acylating. So option A is the correct option. Okay. Next, which of the following is more stable complex and why? CONS3O6 and CON. Can you see that here? What is there? It is chelation will happen. Chelation, and chelation stability को क्या करता है? Increase करता है. Stability increases. So this one is the correct option. Not a big deal. आगे बढ़ो. Which of the following is ambidentate ligand? Ambidentate are those जो कि दो तरफ से from more than one type of different atoms it can show the density. So SCN through sulfur as well as through nitrogen. Next, nomenclature of the coordination compound. Very important questions come from here. Nomenclature में हम क्या करते हैं? हमेशा cation को पहले नेम किया करता है और anion को बाद में. So it may be cation may be complex or it may be a simple cation or anion may be complex or simple anion. So whatever is cation, first of all, either it is complex or simple, no problem. You will have to name it first and later on you will go for the anion. जैसे कि सोडियम क्लोराइड में पहले तुम बोलते हो सोडियम and then you call it chloride. Never you say chlorine sodium, right? Or chloride sodium, right? Understanding it. So rules for writing, I will not go for all these rules, please, because you already know, I hope. So directly come to the question. Write the IUPAC name of the following coordination compound. So always remember what you are going to think about. Can you see that क्या यहाँ पे क्या है? Can you see कि कोई भी ion है? No, because the overall charge is showing 0 because there is neither positive counter ion, neither it is negative counter ion. So सीधा नाम लिखो. सीधा नेमिंग के लिए क्या किया जाता है? First of all you start with ligand and first of all you have to name that ligand that is alphabetically coming first. Can you see ammonia? Ammonia के लिए क्या है? Amine. Amine start with A. Chlorine start with CHLO. So C. Nitro. It is nitrite. So it is nitrito. So can you see how many of the ammonia is there? 2. So it will be called diamine. क्लोरीन कितने हैं भाई? उसके बाद तो C आता है. क्लोरो और क्लोराइडो, एनीथिंग. It is called nitrito. Then platinum के ऊपर चार्ज कितना? Can you see here? Chlorine has the charge -1, nitrite has the charge -1. So platinum has the charge how much? +2. So because overall charge is 0, so if complex has charge 0 or positive, metal named as it is, but as the complex has the negative charge, so in such case what you will say? You will call metal named with suffix 8. Means here it is called platinum because overall charge is 0. So I will directly call platinum. Acha, how much of the charge is there? 2. So in Roman number, write it with the parenthesis platinum 2. So diamine, chloro, nitrito, platinum 2. That's it. Simple. Next, talk about it. Can you see counter ion? Yes, counter ion here it is positive. How much it is? Do not think about the how much. It is potassium. Potassium के बाद क्या लिखोगे? Now come to the negative part. Negative part पे charge कितना है? Because there are 3 negative, 3 positive. So therefore, how much of the negative should be there? 3 negative. Now oxalate has how much of the negative? 2. So how many oxalate are there? 3. So overall negative how much? -6. So 6 के बाद भी how much of the negative it is showing? -3. So 3 negative is cancelled. So who has cancelled this 3? Chromium. So chromium has charge how much? +3. Simple oxidation number finding. Next, How many of the oxalate is there? 3. So what you will say? Trioxalate 2. And sometimes this is also used as tris. Oxalate के लिए tri और tris दोनों use होता है. Tri in the old notation, while in new notation oxalato comes with the tris. Whenever there is any molecule that has the di, tri, tetra, these things in its name itself, like ethylene diamine. So di is inside the name. So what do you use? If let's say 2 ethylene diamine is there, so you will call it bis. Let's say 3 is there, so tris. 4 is there, tetrakis, 5 is there. I hope you understand it, so on and so forth, right? Now, so it is either tri or tris, no issue. Oxalato, then chromium. Chromium is third, yes or no, but overall negative is negative. Overall charge is negative. If the overall complex is negatively charged, the metal named with the suffix 8. So it will be called chromium. Chromium is there. So chromate. Chromate. And bracket mein likho whatever is the oxidation number, that is 3. Third. So now I will not write, I will directly ask you. Here can you see overall charge is positive or negative? Plus. How much? Because chlorine is -1, so overall charge will be plus. Means the cobalt name will come as directly as cobalt. So how will you call it? Because I will name it here because it is a different kind of naming. So here ethylene diamine, it is coming with C, it is coming with E. So E comes later, C comes first. So it is chloro, then ethylene diamine, the name di itself inside it, so therefore you will use bis ethylene diamine, ethylene diamine. Now what is that? Cobalt के लिए कोबाल्टेट मत करना. Why? Because overall charge on the complex is positive, so cobalt will name as it is cobalt, not cobaltate. Cobalt 3. How much of the charge is there? 3. Chloride. Not a big deal, easy one. Now you can just do that also. Okay, चलो आगे बढ़ेंगे. Now name of the complex FeCN6 3 minus. Iron has how much of the charge? Plus 3. Overall negative, so ferrate. How much of the cyanide? 6. So hexacyano iron third. No, not iron. Ferrate third. Hexacyano cyanide 2. No. Hexacyano ferrate third ion. अरे बिल्कुल सही option. Next, the correct IUPAC name for CrF2En twice Cl. Can you see chromium here? Overall, how much of the negative is there? Here -2. Here it is -1. So overall chromium will have +3. What we can say? Ethylene diamine, E comes first or F comes first? E. So can you see bis ethylene diamine and difluoro. Here bis is not given, no issues. You can go. Means it is going with the old notation. Sometimes see the before 2005 IUPAC 2004 IUPAC convention used to say that you have to come first of all whatever is the polydentate ligands are there, that you have to use later. Okay. So here that's why it is used later. Though its name should be first, but new rule says that it has only have to go with the alphabetical order. Earlier it was told that first of all you have to use the negatively charged and then you have to go for the neutral, and later on you have to go for the positively charged. So it is following this because fluorine is having -1 and ethylene diamine is having 0. That's why it is following the rule of IUPAC rule of before 2004. So first of all fluoride is being used and later on this neutral ligand is going to be used. Okay. Now so difluoro bis ethylene diamine, chromium third. Chromium or what? Of course chromium third chloride. So option D is the correct option. Next, IUPAC name PT. This is what? Now I hope it is all very clear. First of all, you will give the name for bromine, then chlorine, amine, then bromine, then chlorine, and then nitro. First this, then this, and at last nitro or nitrito. So you can just do that, nitrito. And here it is overall platinum is how much? +4. Can you see? Perfect. Platinum is +4. So platinum 4 because overall is charge is positive. So therefore platinum 4. So can you just see that? Can you check that? You can do it, I hope. Now the correct increasing order of electrical conductivity in the aqueous solution. Electrical conductivity depends on the number of ions. So what we can say? Electrical conductivity depends on the number of ions. Whatever is the more number of ions, that will be more ionic. Can you see? One complex and 4 here. Overall how many? 5. Can you see? 1 complex and how many chloride? 3. 1 plus 3 is how much? 4. Can you see? It is how much? 1 complex and how many chloride is there? 1. So overall how many? 2. Can you see? 2 normal and 1 complex. It is how much? 3. So maximum will be 1, then 4, then 2, 9, 1, 2, 4, 3, 1, 2, 4, 3. 1 is more than 2 is more than 4 is 3. Okay. Effective atomic number, EN rule. What is EN rule? EN rule given by Sidgwick. What it says? It says that in the process of formation of coordination compound, whatever is the total number of electrons that any central metal atom or central metal ion has, it is called effective atomic number. And if any metal has effective atomic number equal to its next noble gas electron or number of electrons, so it will be called, so it will be more stable. So that is the rule, effective atomic number rule. I'm not giving you all these things, writing all these things, because I hope that you already know about these things. Now one more thing, where is it really very much, very effective rule? No, it is not a very effective rule, but yes, at one place it is very effective. Where it is effective when the carbonyl compounds are there. When carbonyl compounds are there, then metals use or metal follow this EN rule, like this, they follow it, really they follow it. Now see how, rather than talking, directly talk about it. Write it. एथिलीन डायमीन के लिए फॉर्मूला क्या होता है? अरे सॉरी, व्हाट आई एम डूइंग. इफेक्टिव एटॉमिक नंबर के लिए फॉर्मूला क्या होता है? इफेक्टिव एटॉमिक नंबर के लिए फॉर्मूला सिंपल सी बात है भाई. व्हाटएवर इज द Z means whatever is the atomic number of that metal is there, a central metal ion is there, plus whatever is the ligand is there, ligand multiply with 2, because every ligand is going to give how many or how many bonds, whatever is not just ligand, you can say number of bonds, number of coordination number multiplied by 2, minus whatever is the positive charge, minus of the positive charge on central metal atom. Okay, any doubt? So that is how you can find out. So let's see example. Few examples I'm directly taking, and I'm only taking the carbonyl example. I'm not taking any other example. Okay, like I will take some other examples also. Okay. CO 6 3 plus. Next is FeCN 6 3 minus FeCN. पहले तो Fe take time. 6 4 minus MnCO 5. MnCO 6. Next, BCO 6. Chalo, let's find out. How much of this can you see? Cobalt has how much of the charge? 3. How many of the carbonyl are there? 6. So 6 2s are. First of all, what is the cobalt ka? What is the Z? It is 27. Plus, how much is this? Plus 12. Minus how much? Minus of 3. It is how much? It is 12 minus 3 is how much? 12 minus 3 is 9. So it is 36. Can you see? 36 is nothing but it is equal to krypton. So therefore it is what? Effective atomic number is equal to krypton. So it is stable. It is very stable. Neither gives electron nor lose the electron nor take the electron. So neither it will act as oxidizing agent nor it will act as reducing agent. Now let's talk about MnCO6. Mn is how much? 25. How much is the charge on manganese? 0, because carbonyl has also how much charge? 0. So how much of this are there? Carbonyl are there? 6. 6 2s are how much? 12. How much it comes? Is there any charge? No, nothing. So therefore it is 37. So 37 is not equal to 36. So therefore what we can say that means it can lose one electron. It can lose one electron to convert into 36. After losing it, it converts into MnCO6 plus. So therefore it will act as oxidizing agent or reducing agent. Something that gives the electron that will get oxidized. So it is acting as reducing agent. What about this VCO6? Vanadium. Vanadium is how much? 23. How much is this? CO6 is how much? 12. 6 to the 12. It is how much? 35. Now it will try to take one electron. it will try to take one electron. Why? To complete equal to 36. Just to try to complete equal to 36. Why? Because it needs to, because it is carbonyl compound. I told you in carbonyl compound, they follow it, blindly. So what we can say, to make it 36. So what will be that? VCO6 minus. So therefore VCO6 minus. So for converting into it, it will have to take the electron. So after taking electron, it gets reduced. So it is acting as oxidizing agent. So it is acting as oxidizing agent. So question may also be coming like that, right? Now you can find out as a homework. I'm just giving you FeCN6 -3 and -4 to find out effective atomic number. Next, apply the concept of effective atomic number on the complex FeCN6 4 minus and FeCN6 3 मान लो question ही आ गया. What conclusion do you draw about the validity of the EN rule from these two complexes? Can you see what is that? Fe, how much is the charge here? +2. Fe is how much? 26. Charge is how much? -2, because +2 is there. How much is there? +12, because there are how many? 6 is there. So it is 36. It is having equal to krypton. So therefore it is stable. It is stable. It is more stable. Can you talk about it? So here Fe is +3. So therefore it will overall, it will come, effective atomic number will come, EAN will come 35. That is not equal to 36. So it is less stable. So this is something that is the conclusion that you can get from it. Next, bonding in coordination compound. There are many of the bonding theories in coordination compounds are given, like valence bond theory, next crystal field theory, and next is molecular orbital theory. But it is not in syllabus, but these two are, they are in syllabus. When I was yesterday, I was talking about chemical bonding. That time also I told you the molecular orbital theory is answer to every question in chemistry. If it is talking about bonding, if you talk about bonding, it is like, it is for everything. So MOT can act for answer for any question. But the point is, we are not going to study because ये हमारे syllabus में नहीं है. I'm not going to the theories much. I'm directly coming. See, VBT, what it considers valence bond theory. Valence bond theory says that if there is, let's say, if there is bonding is going to happen, so always the vacant d orbital of the metal and the filled orbitals or filled orbitals of the ligand overlap with each other, and due to overlap only the bonds are formed. So let's say that metal has to form 6 bonds, or let's say there are 6 different bonds it has to form. So it will vacate 6 different orbitals and just intermix with each other. And once they intermix with each other, you understand what will happen. Hybridization will come in the picture. Let's say 2 orbitals are being mixed. So what it may be either sp or sd. Let's say there are 3 are there, so sp2, or either you can go for like not 3, generally it comes 4. So what we can say sd3 or sp3. Then if it is coming, it may also be dsp2. That will tell you about square planar. If you come to 6 or 5, then it will be sp3d. I hope you all know that how it is, trigonal pyramidal. If d is dz square, it will be trigonal pyramidal. But what if it is sp3d may the taking part is dx square minus y square, it will become square planar pyramidal, square pyramidal, right? So if dx square minus y square is taking part, it will be square pyramidal, while if it is dz square is taking part, then it will become trigonal bipyramidal. Simple one. Then if you talk about sp3d2, that is nothing but it is octahedral. Here dx square minus y square and dz square is taking place. Other sp3, so I hope you understand what are these going to take place. Okay, not a big deal. आगे बढ़ेंगे. चलो आगे बढ़ते हैं directly. Come to the question. Determine which of the following statements about VBT is inaccurate. It does not explain the color of the coordination compound. Yes, it is correct. What it is asking for? Inaccurate, but it is accurate. It can distinguish between strong and weak field ligand. No, strong and weak ligands are given in crystal field theory. Please keep in mind. Next, it does not explain the kinetic stability of the coordination compound. Yes, it does not explain the structure of this. It does not explain the. Okay. Acha, it can distinguish. Acha, it is telling it can distinguish. Array, तब तो option B, because it cannot. The reality is it cannot. Okay. That's correct. चलो भाई आगे बढ़ेंगे. Next, this is very important. This is very beautiful complex, and it has a complete story that how and what initially was thought. Because due to spectroscopical study, we thought that we got to know that this is planar. If it is planar, of course, it should have a square planar geometry because coordination number is 4. Only two possibility. One is tetrahedral, one is square planar. So according to sp2 square planar, it was considered to be that it will be dsp2, but no, it was not dsp2. Why? Because later on it was found out कि नहीं ऐसा नहीं होता है. Why it was not? It was a completely different question. Then we came to the three different explanations. Then comes the final explanation. What you have to consider that sp2d is the correct option for its hybridization. So here d, not the 3d is taking part, but 4d is taking part. So therefore it is not dsp2, but it is sp2d. What is the hybridization for this? It is sp2d. But is it the final answer? No. Later on comes the John Taylor and John Taylor distortion. According to John Taylor theory, distortion theory, it says that ये जो molecule है, it is the John Taylor distortion molecule, and basically it does not have any kind of hybridization. It does not have a hybridization at all. पर आपको क्या रखना है याद? जो आपको याद रखना है मैंने आपको बता दिया. Next, the spin only magnetic moment of this is 5.9. Predict the geometry of the complex. Can you see whenever I was talking to atomic structure, in atomic structure I told you whatever is the whole number means that much is the number of unpaired electrons. So how much is the whole number? 5. So unpaired electron is how much? 5. When manganese will have 5 unpaired electron, because we know that manganese is how much? Anyways, bromine is how much? -4. So here manganese is how much? +2. So Mn plus 2. So can you see it is what? 4s0 3d 3d 5 4s0 and 4p0. Can you see 3d5? And bromine is a weak field ligand. It is what? Weak field ligand. And how many of the bromine is there? 4. So can you see what will happen? 1 2 3 d. Can you d को fill karo zara bhai? 1 2 3 4 5. All the d are filled. So because it is a weak field ligand, there is not going to be any kind of pairing up नहीं होगा. छोड़ो s. फिर उसके बाद क्या आता है? 3p. How many of the bromine we have to accommodate? 4. So 1 in s, 3 in p. So what is that? sp3. So sp3 will tell you nothing but tetrahedral. What is the geometry? Tetrahedral geometry. Next, आगे बढ़ो. Crystal field theory. Crystal field theory is a different kind of theory or different kind of approach for seeing any molecule, coordination molecule. It considered that central metal atoms are nothing but they are point charges, point positive charges, and all the ligands are nothing but they are point negative charges, or you can say point dipoles. Let's say if there is something neutral, it will consider it point dipole. If it is negatively charged, it will consider it point negative or point anion. Okay. Now, in such case, what happened in crystal field? The bonds were found to be, or it was imagined to be, purely ionic. Okay, this was one of the problem with the crystal field theory. What it tells you about? It tells you about the state that how the ligand and metal approach each other. First of all, they will approach to each other. Then once negative and positive will approach, what will happen? They will attract each other. Once the attraction will happen, potential difference will, or you can say potential energy will decrease. As it comes decrease. At a point, what will happen? They will come so close that again the potential energy will start increasing, and it will increase up to a certain level that is called Barry energy center or average Barry center, Barry energy center level, or average Barry energy. And once it goes up to there, because all the ligands are not symmetrically approaching to the central metal atom, due to that what happens? The d, whatever is the degenerate orbitals are there. How many of the degenerate orbitals are there in d subshell? There are 5. But due to the unsymmetrical approach of the ligand, that breaks into few parts. If let's say there is octahedral, geometry is there. So in octahedral geometry, what happens? The breaking is something like that. Eg will be up, T2g will be downside. What is this Eg? Eg is nothing but it is telling you about there are two different degenerate orbitals are there. T2g is telling you about the 3 different degenerate orbitals are there. G is nothing but it is about the Girard symmetry. Do not think about it. This difference is how much? This is delta O. Delta O is nothing but crystal field splitting energy in the octahedral field. This Eg, because the overall average energy should be maintained, this should be plus 0.5. It is nothing but it is plus 0.6 delta naught. And how much is this? It is nothing but minus 0.4 delta naught. Please keep in mind. Now whatever is the number of electron you are filling, just fill it according to the Hund's rule. Not a big deal. कर लो भाई आराम से, एकदम प्यार से हो जाएगा. उसके बाद what you have to do, then you have to find out crystal field stabilization energy, that is equals to number of T2G electron multiplied by minus of 0.4 into delta naught plus number of EG electron multiplied by plus 0.6 into delta naught. Please, plus if there is any electron that is paired up, that to paired up, from your side, not naturally, then you have to add that number of forcefully paired electrons, that is NP. That is something that I hope you all know. We'll see if there is any question. Now in tetrahedral geometry, how it breaks something like that. T2G will be going up, EG will come down, okay, and this difference is nothing but is delta T. How much is this difference? This difference is, it is plus 0.4 delta T. How much is this difference? This difference is minus 0.6 delta T. Any doubt? No doubt. I think it is all very clear. So delta T plus 0.4 minus 0.6. Minus 0.6. So I hope just for making the or keeping the average constant, this splitting is in such a way. Okay. Now, how do you find out CFSE here? Crystal field stabilization energy in this case will be given as for EG. So number of EG, not EG, but number of E electron. I am not using G because it is not G-rate symmetry. Here G-rate symmetry is not there. That's why G is not used. So number of E electron multiplied by 0 point minus of 0.6 into delta T plus number of T2 electrons multiplied by plus 0.4 delta T. तो यहाँ पे पेयरिंग की बात मत करो क्योंकि यहाँ पे पेयरिंग ड्यू टू स्ट्रॉन्ग फील्ड और वीक फील्ड लिगेंड का इशू ही नहीं होता है. देयर इज नो इशू. व्हाई सो? बिकॉज जो डिफरेंस बिटवीन डेल्टा टी जो होता है वो इतना कम होता है, पेयरिंग की जरूरत ही नहीं पड़ती. इट इज वेरी बहुत आराम से चलता है. यहाँ पे पेयरिंग वाला इशू नहीं आता बिकॉज द स्प्लिटिंग इज नेवर सो हाई, राइट? व्हाई? यू कैन सी दैट द रिलेशनशिप बिटवीन डेल्टा टी एंड डेल्टा नॉट इज समथिंग लाइक दैट. डेल्टा टी इक्वल्स टू 4/9 इंटू डेल्टा नॉट. देखो यार, स्प्लिटिंग तो यार स्क्वायर प्लेनर में भी होता है, पर स्क्वायर प्लेनर स्प्लिटिंग इज नॉट देयर इन योर सिलेबस, बट स्टिल इफ इट इज समवेयर, लेट्स से इट इज आस्क्ड, तो आंसर जान लो, कोई दिक्कत नहीं है. स्प्लिटिंग कुछ ऐसे होता है कि डी एक्स स्क्वायर माइनस वाई स्क्वायर, नीचे आएगा डी एक्स वाई, उसके नीचे आएगा डी जेड स्क्वायर, सबसे नीचे आएगा डी डी एक्स जेड एंड डी जेड और वाई जेड, डी वाई जेड. दीज विल बी एट द लोस्ट, तो यहाँ पे जो डेल्टा एस पी होता है, व्हाट विल बी द रिलेशनशिप ऑफ डेल्टा एस पी एंड डेल्टा नॉट? सी, delta sp is maximum. It is how much? 1.3 delta naught, even more than delta naught. Delta t is minimum, so delta sp is more than delta naught, or delta octahedral is more than delta tetrahedral. Keep in mind these points are very important. Next, amongst the following, which one has the highest magnetic moment value? Now magnetic moment के लिए everyone you know that mu equals to root of n into n plus 2. Here n is what? N is the unpaired electrons. Unpaired electron. Can you see here chromium is how much? Plus 3. Chromium plus 3 मतलब it is D3. D3 मतलब कितने unpaired electron? 3. 3 unpaired electron. So therefore mu will be equal to 3.9 Bohr magneton, something like that. What about that Fe plus 2? Here Fe plus 2 means D6. So therefore how many unpaired electron is there? 4. Because it is what? Weak field ligand. Not a big deal. Weak field ligand. So therefore mu is equals to 4.9 Bohr magneton. What about this zinc plus 2? Here it is D10. So therefore it is number of unpaired electron is how much? 0. Because D10 में क्या हो जाएगा? सारे के सारे pair up हो जाएंगे. So therefore what will happen? Mu will be equal to 0. बात ही हटाओ. इनकी बात करो. CO plus 2. It is D7. D7 है मतलब what will happen? 2 electrons will be paired up. 3 will be left. N equals to 3. So therefore mu will be equal to again 3.9 Bohr magneton. Maximum कहाँ पे आ गया? यहाँ पे. Option B is the correct option. Not a big deal, easy one, right? CFSE of the octahedral, this is this much. Then CFSE for the tetrahedral, this will be, okay, can you see it is octahedral? It is what? Octahedral. Octahedral delta naught की value कितनी दे रखी है? 18,000 centimeter inverse. Can you see how many of the coordination number is there? Coordination number was 6. That's why octahedral. Can you see here it is what? Tetrahedral दे रखा है. And it is what? Coordination number is 4. So I hope you all remember delta t और delta o के बीच का relation. Delta t equals to 4/9 of delta octahedral. That will be 4/9 of 18,000. Cancel 2,000 into 4 is how much? 8,000. Cancel. Option C is the correct option. Next, crystal field stabilization energy is high spin. High spin means no pairing up, no pairing, no pairing up, no pairing up means weak field ligand is used. Weak field ligand is used. Okay, D4 है, जरा सोचो कैसे ऑक्टाहेड्रल में ब्रेकिंग होता है, T2G एंड नीचे ऊपर क्या होता है, EG. हाउ मेनी ऑफ द इलेक्ट्रॉन्स आर देयर, 4. 1 2 3 4. चलो भाई जरा सोचो, इट इज व्हाट, आई होप यू ऑल नो दैट whatever is CFSE कैसे फाइंड आउट करना है, CFSE will be equal to number of electron in T2G orbital, that is how much, 3 into T2G का कितना एनर्जी होती है, माइनस ऑफ 0.4 इंटू डेल्टा ओ प्लस ईजी में कितने इलेक्ट्रॉन है, 1. इसके लिए कितना होता है, प्लस 0.6 इंटू डेल्टा ओ, दैट इज हाउ मच, 3 4 12 माइनस ऑफ 12 डेल्टा ओ. यहाँ पे कितना हो गया, प्लस 0.6 डेल्टा ओ, इट इज हाउ मच, प्लस सॉरी माइनस ऑफ 0.6 delta O is the correct option. Where is minus of 0.6? Option D is the correct option. Okay, next H2O, this has a magnetic. चलो अच्छा एक क्वेश्चन और, इसी मान लो अगर इसने ना बोल के हाई स्पिन बोल दिया होता, अगर मान लो इसने बोल दिया होता लो स्पिन, तो लो स्पिन के लिए क्या करते, मतलब इट वाज गोइंग टू बी टॉकिंग अबाउट स्ट्रॉन्ग फील्ड लिगेंड. स्ट्रॉन्ग फील्ड लिगेंड पे कैसे हो जाता, इट वुड बी समथिंग लुकिंग लाइक दैट, 1 2 3, फिर यहाँ पे पेयरिंग अप हो जाती, ऑल द इलेक्ट्रॉन विल कम इन द T2G. If T2G, then what will be there, 4 into minus 0.4 delta naught, that will be minus of 1.6 into delta naught. And because you are doing one pairing against the will, so therefore one pairing energy will also have to be added. So minus of 1.6 delta naught plus pairing. So option B will be the correct option. देखो जरा ध्यान से सोचना, बहुत प्यारा क्वेश्चन है. So you could make a mistake if you have done with that, no? If you would have gone with that method. Okay, so for low spin also I have told you how you'll go. Next, for this has a magnetic moment 3.83, means we can say that there are 3 unpaired electrons are there. The correct distribution of 3D electrons. Okay, can you see it is what? It is plus 3. So plus 3 is there, means it is D3. D3 is not a big deal. D3 है, क्या आपको दिख रहा है कि water क्या है? It is a weak field ligand. Why? How am I saying it something is weak field ligand or weak strong field ligand? Let me note it down. So how do you say, let's say I'm just giving you few of the things, ये याद रखना, आयोडीन से ज़्यादा ब्रोमाइड, ब्रोमाइड से ज़्यादा सल्फाइड, सल्फाइड से ज़्यादा क्लोराइड, क्लोराइड से ज़्यादा नाइट्रेट, नाइट्रेट से ज़्यादा क्लोराइड से ज़्यादा ऑक्सलेट से ज़्यादा वाटर. मोर देन दिस इज अमोनिया से ज़्यादा, इसको बाई EN से ज़्यादा, CnO2 माइनस नाइट्रेट ऑफ इस से भी ज़्यादा, इट इज गोइंग टू बी Cn माइनस से भी ज़्यादा CO. So all these I am writing down. It is strong field ligand, strong field ligand. अमोनिया को भी ले सकते हो, but it is moderately strong. It is moderately strong. That is pink. While all the white are nothing but these are weak field ligand. जितने भी white वाले हैं weak field ligand है. Ammonia is moderately strong, while all these are strong field ligand. Not a big deal. I think it is all okay. Okay, now because water is a weak field ligand, so there is no pairing up. No pairing. अगर कोई pairing नहीं होगी तो जरा सोचो what will happen. Here it is D3 because it is octahedral, 1 2 3. So all of them will be in T2G. T2G में कौन कौन से होते हैं? Always remember T2G are DXY, DYZ and DZX. While EG कौन कौन से होते हैं भाई? EG को भी याद रख लो, DX square minus Y square, that is axial ones, and DZ square. So where all the electrons are there, it is there in the T2G orbital, and T2G orbital में कौन कौन से होते हैं? DXY, YZ and DZX. So which is the correct option? No, not this one. Option B. Any doubt? No doubt. Next, which of the following statement is correct? Correct. Okay. So following statement is correct. Okay, just see that NiCO4 is diamagnetic. Can you see CO is a strong field ligand? Arey yes, बहुत very strong field ligand. So Ni is here what? It is D8. How much is the charge here? 0. So it is 3D8 4S2. But what will happen due to a strong field ligand? These electron will come inside and it will become 3D10 4S0 and 4P, आगे 0 वाला ये सब. So what is that? Can you see that? Is there any unpaired electron? No unpaired electron. No unpaired electron. So because it is 3d10, so therefore what we can say? Number of unpaired electron equal to 0. So therefore mu will also be equal to 0. So just a minute. So it is diamagnetic. यहाँ तक तो सही है. NiCl4, NiCl4. Here Ni is +2. Can you see Cl is what? Weak field ligand. So therefore no pairing. No pairing. Can you see? It will be 3d8 4s0 4p0. Can you see what will happen here? Of course we can see that it is going to be tetrahedral because 3d8 is there. So can you see 1 2 3 4 5 6 7 8? How many of the unpaired electron are there? So unpaired electron is 2. So therefore mu will be equals to 1.73 Bohr magneton. Can you see? Now what we are going to see? Cyanide. So therefore it is what? It is paramagnetic. Yes, it is paramagnetic. यहाँ तक तो सही जा रहा है. NiCl4. Ni is here how much? +2. Here again it will be 3d8 4s0. But here what will happen? Cyanide being a strong field ligand, यहाँ पे क्या हो जाएगा? Pairing हो जाएगी. Pairing. So pairing होने से क्या हो जाएगा? This d8 will be something looking like that. 1 2 3 1 2 3 4 5 6 7 8. All the electrons will be paired up and this will come dsp2. इसका क्या आ जाएगा भाई? Hybridization, it will come dsp2. Basically 1d will be free here. What we can say? All the electrons are being, so here being paired up, so n equals to 0. So here also mu will be equal to 0. So therefore it is what? It is diamagnetic. No. So NiCO4 and NiCN4 are diamagnetic and Ni. Yes, option B is the correct option. Next, FeH2O6 is strongly paramagnetic, whereas this is weakly paramagnetic. Explain. Can you see? It is what? Weak field ligand. Weak field ligand. While it is what? It is strong field ligand. I hope you can see that due to weak field ligand is what? D +2 is there. No, +3 is there. So therefore it will come D5. Here also it is +3 is there. So it will also come D5. But here what will happen? Strong field ligand will pair up. While here what will happen? It will no pairing. No pairing. So because there is no pairing, so what will happen? It will something looking like that. 1 2 3 4 5. So there is number of unpaired electron comes to be 5. So therefore mu will be equal to 5.9 Bohr magneton. What about that? It is pairing. It is going to be paired up. 1 2 3 4. Sorry. 1 2 3. After third electron you have to pair up. Never ever pair up before 3. So first of all 1 2 3 and then pair up. So how many of this? You can see that 1, only 1 unpaired. Number of unpaired electron equals to 1. So therefore mu equals to root of n into n plus 2. That is how much? Root of, so 1.41 Bohr magneton. Can you see? So I hope you all can see that here mu is equals to very high, while here mu is equals to very less. So explanation, I hope you all could see. Now let's come to the synergic bond. Whenever there is metal carbonyl bond is there, whenever there is metal carbonyl bond, where we see that in the metal carbonyl bond. In metal carbonyl bond, what happens? Please listen to me very carefully, and I will directly write the effect of this synergic bond. If a ligand donates electron pair to the metal atom or ion and accepts electron pair from d orbital of metal ion, then it is called synergic bond, and ligand is called as pi acceptor ligand. Please remember, whenever metal carbonyl bond is formed, first of all, carbonyl gives the lone pair to the metal. It is the sigma. It is of the sigma nature because it is a new first bond is going to be formed. But then what happens? Metal has the electron in its d orbital that it provides in the carbonyl pi star anti-bonding. You can say pi anti-bonding orbital. So what happens? This MC bond becomes metal carbon bond becomes, you can see that it is not single bond, but it becomes multiple bond character. So what happens? So here, due to multiple bond character, MC bond becomes very strong. But the electrons are being accepted in the pi star, that is anti-bonding orbital. Due to that, whatever is the already present CO bond that becomes weak. Why? Because the electron is being filled in the anti-bonding. और जैसे ही anti-bonding में electron आते हैं, हमारी एनर्जी क्या हो जाती है? बढ़ जाती है. कार्बोनाइल की एनर्जी बढ़ जाएगी तो स्टेबिलिटी क्या हो जाएगी? डिक्रीज. तो देयरफॉर व्हाट वी कैन से, कार्बोनाइल के लिए बड़ा ही सिंपल सा गेम है भाई. ड्यू टू synergic bond, what happens? Please remember, due to synergic bonds. Due to synergic bond, what are the things? Effect क्या होता है? Effect मैं लिखता जा रहा हूँ. First, MC, bond strength increases, so bond length will decrease. Second, CO, bond strength decreases, so bond length will increase. Third thing is frequency of CO bond increases, because bond decreases due to synergic bond. It is all due to synergic bond. एक बहुत important point कि extent of synergic bond is directly proportional to negative charge on central metal atom, but it is inversely proportional to positive charge on central metal atom. अगर central metal atom positive charge है तो metal कहाँ से? If metal has positive charge, so it cannot give the electron. If it has negative charge, so it can give the electron easily. So if it can give the electron easily, so synergic bond will be stronger. So I hope you understand. So these effects will also become stronger. क्या ये बात पक्का समझ में आ रही है? चलो आगे बढ़ो. Which of the following has higher multiple bond character? Multiple bond character मतलब stronger की बात कर रहा है. MC bond मतलब ये किसकी बात कर रहा है? Higher synergic bond. Higher synergic bond. Higher synergic bond कब होगा? मतलब high synergic bond. High synergic bond कब होगा? When metal has negative charge. When metal has negative charge. Is there any negative charge? Yes. Negative charge -2, -1. Maximum is here. So option C. B and C both have equal multiple. No, it has more multiple bond character. The reason being more higher negative charge. Any doubt? Next. VC distance is in VCO and VCO minus R respectively. Can you see? चलो थोड़ा देखते हैं and find out करते हैं. VC मतलब again it is asking for MC bond. MC bond character, bond distance is asking. So bond strength of MC is directly proportional to synergic bond. We have already studied. So therefore it is inversely proportional to bond length. चलो और जरा देखो कहाँ पे ज्यादा होगा? यहाँ पे synergic bond is high. क्यों? Negative charge. Here synergic bond will be less. अगर synergic bond is high, so bond strength of VC bond will be high. So therefore bond length will be less. Bond length here is less, here is more. So more should be for VCO and less for this. So it is, both of them are same. No, it should be having more. Wrong. Here it is less and here it is more. So option C is the correct. More, that is more for this and less for that. I hope you all can see that and easily understand it. Among the following complexes, which can act as oxidizing agent? See, here I have already talked about it. Oxidizing agent की तरह कौन करेगा? जहाँ पर yes, effective atomic number rule. Here what is that? Here it is 37 EAN. So to convert into 36, it will be removing one electron. It will convert into MnCO6 plus. So because it is removing an electron, so therefore it is getting oxidized. So it is acting as the reducing agent. What it is asking for? Acts as oxidizing agent. No, तो ये तो reducing agent है. MnCO6. ये किसकी बात करो भाई? यहाँ पे effective atomic number is already 36. It is not going to do anything. MnCO6. Can you see? Can you see? Directly I'm thinking about VCO6. Can you see what is the effective atomic number? EAN. Effective atomic number is how much? Here it is 23 plus 12. That is 35. So it wants to convert into 36. So what it will do? It will accept one electron to convert into VCO6 minus 1. Now effective atomic number comes out to be 36. Now in such case, what we can say? VCO6 is converting into VCO6 minus, so effective atomic number is becoming 36. So now it is acting, it is taking electrons, so it is getting reduced, so it is acting as oxidizing agent. Option D is the correct option. Any doubt? Next is, which of the following does not have a metal carbon bond? AlOC2. Of course here metal oxygen bond is there. Metal oxygen bond. No. Here metal C. Of course here it is Grignard reagent. Option A is the correct option. Here Grignard reagent, here PT, and it is ethylene directly. Double bond will be, it will be giving the pi bond donor. Here nickel and carbon will have the direct. Yes, option A is the correct option. Next, Isomerism is coordination compounds. What are the isomerism? Isomerism के भी two types हैं, structural isomerism and stereoisomerism. In structural isomerism, we study about many like solvate isomerism, coordination isomerism, ionization isomerism. There are a lot many. I hope you can see that in the NCERT. You can read that. Not a big deal. बहुत ही easy options हैं. You can just go through them and you can understand very easily. And whatever the examples are given in NCERT, that becomes utmost important, very important. Next, directly come to the stereo isomerism. There are two. One is the same thing that we have studied in that you study in organic compound, that is geometrical isomerism, and another is optical isomerism. It is due to three-dimensional, whatever is the three-dimensional arrangement. Due to that, this OI and GI comes. OI के लिए क्या होना चाहिए? No symmetry should be there. No symmetry should be available. Basically, plane of symmetry should not be available. What about GI? GI should have different arrangement of atoms or ligands around the central metal atom or central metal, and not a big deal, easy one, right? आगे बढ़ो, चलो. Now we are here there in the total number of geometrical isomerism M, A, B, C, D. Now general formula are there. I hope this is something that's only for your remembering. Now I'm giving you time. You can just take the screenshot. 1, 2, 3, 4, 5. Or you can just rewatch this video again. Now again, there are all these types of these what complexes are there. When it's what are the number of stereoisomers are there, and what is the pair of enantiomers? Pairs of enantiomers means it is talking about the optical isomers. Okay, means it is talking about optical isomers. पीछे हमने क्या देखा? We have studied about geometrical isomers. It is what? Geometrical isomers. Now total number of, just a minute, and total number of stereoisomers is nothing but geometrical isomers plus optical isomers, and it is what? Optical isomers. Okay, any doubt? So when it will show optical isomerism, when it will not show, always remember few things you have to remember as a rule. First of all, फिर से you can take the screenshot, you can read it and just make a note out of it. Question comes from here. Next, always remember, see, there are a lot many things we have to give you in isomerism, but we know that it is just a revision class. Now see, so if there is octahedral molecule is there, if let's say tetrahedral molecule is there, or let's say there is square planar molecule is there. So octahedral and square planar mein, when something will show geometrical isomerism and when something will show optical isomerism, let's see. Octahedral shows both GI and OI. It can show, not always it will show, it can show. Now tetrahedral always remember कि ये कभी भी, now just think about it, it will never show GI because all the positions in tetrahedral are symmetrical positions are there, but it can show optical isomerism. When it can show? When it is M, A, B, C, D, when all the ligands are different. Okay, next, in square planar, what it can show? It can show GI, but it can never show optical isomerism. Why so? Because it has a plane, and if something is plane, of course it has the plane of symmetry. That plane, the molecular plane itself starts acting as the plane of symmetry. Is that okay? Next, chalo. Now these are the formula, pairs of enantiomers. This is something I hope you all can do. Kar lena bhai, please. Whatever I have told you, these things are of very much essence, very much of importance. Chalo. In particular isomer of this, the CL angle is 90 degree. The isomer is known as, देखो, अब इसमें there are two possibilities are there. It may be cis or trans. It may be cis or trans. What is that? It is MA4 B2 type of is there. It may be either cis or it may be trans. And cis trans is for GI, geometrical isomerism. Can you see? Acha, can you see? Ki CO is there. If Cl goes opposite to each other, ammonia, if both of them go opposite to each other, what is the angle? Angle is 180 degrees. But what if cobalt is something like that, while here Cl comes out at 90 degrees. So what will happen? I hope you can see that ammonia, and ammonia. So therefore what will happen? This will be at the cis position. all these positions. Only the opposite positions are called trans position, while these are called cis position. Because what is the in least number? Least number is chlorine. So either chlorine can be on the trans, so it is called trans, while it is called cis. Cis cup, jabki angle is how much? 90 degrees. Trans cup when the angle is 180 degrees. So it is what? Cis, because it is telling about that CO, Cl, CO, Cl. मतलब Cl, CO, Cl bond. इस bond की बात कर रहे हैं, it is how much? 90 degrees. Can you see? Not a big deal. Easier. The type of isomerism shown by the complex COCl2 En twice. Can you see? It is something, En is nothing but it is a symmetrical bidentate ligand, that is also shown as AA. So how we can say M A2 B, or you can say B, not a big deal. BB also you can say BB2. So we can just call it like that. If you just show something like that, or you can just write like that A twice, not a big deal यार, जैसे भी करना है वैसे करो, कोई दिक्कत नहीं. तो A ऐसे भी show कर सकते, ठीक है. Now what we can see that in such cases it can show geometrical isomerism. Can it show? So coordination, linkage, isomerism, coordination isomerism, linkage isomerism, and ionization isomerism. Always remember कि यहाँ पर क्या हो सकता है. Here again what we can say that M En ethylene diamine, En ethylene diamine, and Cl can go either on the trans or it may go on the cis, like M Cl En, or either it can go something like that En. तो यहाँ पे क्या हो जाएगा? It will be cis. So cis trans is possible. So again it is what geometrical isomerism. देख रहे हो TYQs हैं, क्वेश्चन ऐसे ही आते हैं, टफ नहीं आते, इजी है. Next, number of possible isomers for the complex COEN twice. So do not think about whatever is outside. It is M A twice A twice. क्या के check कर लेना. How many are there? The total number of possible isomers will be 3. Check कर लेना. We have given all those lists. Please. Next, the complex this and this are examples of which type of. देखो हमने दो तरह के isomers पढ़े थे. एक तो अपना structural था, दूसरा था stereo. In the structural isomers, can you see there are two different coordination molecules are there. This ammonia and CN is changing itself, और ये एक दूसरे के जगह change कर रहे हैं, replacing. So as they are replacing each other, what is called, this is called coordination isomers, because coordination के बीच में ligands are changing. So this is called coordination isomers. The complex this will have how many geometrical isomers? Can you see? Because I told you it is what? It is tetrahedral or whatever is this. Just you can just go through it. How many of the GI is there? So I hope you can see that there will be 2. There will be 2. There will be 2. You can just go and check that. Which of the following does not show optical isomerism? See, optical isomerism कौन नहीं show करेगा? Can you see? See, CO it is what? M A3 or M A3 B3 type. M A3 B3 type में it may be 2. Either geometrical. अगर GI की बात करो तो GI में it may show you facial and meridional. That is Fachmer isomerism. Okay. So, but the point is कि does not show optical isomer. Okay, does not show. So this may or may not show. If it is having, if any of the two same ligands are coming on the trans, it will never show. As a rule, if same ligands come at the trans, it will never show. If no same ligands are coming at the trans, it may show, or it will show. In such case, what will happen? Does not follow. It can show. M A twice, of course it can show. CN it also shows. It also shows. So option A is the only correct option that you can go with. So CONS3 whole 4 CO and this exhibits. Acha, can you see what may happen? Because nitrate has 1 negative, chloride has 1 negative, and both of them are very good ligands, so they can exchange their places. One nitrite can go outside, one chloride can inside. So इसे आप क्या बोलते हो? इसे you can say that ionization isomerism. Can it show linkage isomerism? Yes, linkage isomerism is due to let's say flexidentate or ambidentate ligands. Ambidentate ligand. Ambidentate ligand is NO2. Ambidentate, yes, it may be either NO2 or it may be ONO. So either it may be NO2 minus or it may be ONO minus. So of course linkage isomerism is there. Yes, ionization isomerism, yes, because Cl can exchange its place. Yes, geometrical isomerism, can it show geometrical isomerism? Geometrical isomerism की अगर बात करो तो of course it can show cis and trans. It can show cis and trans isomerism, it can show, because NO2 either may be on the trans or it may be on the cis, so it can show. So option A comes out to be, I think, correct. Okay class, so that was all for today's session. We have tried to solve all the important type of questions. Whatever is the question we have solved today, please go through it. And I hope you all will be, you all are taking care of yourself and preparing so well, so hard. So all the best for your preparation. Thank you. Tomorrow we'll come with the GOC session, that is general organic chemistry.